Lesson 5.3. We're going to look at dividing polynomials today. We eventually will get to long division and looking at synthetic division, but what we're going to do first is look at taking a polynomial, okay, and dividing by a monomial meaning a single term polynomial. So if you look at this first example here, we have the trinomial 5a squared b minus 15ab cubed plus 10a cubed b to the fourth. That trinomial divided by the monomial 5ab. If you're dividing by a monomial, so if this is a monomial, okay, you take each term and divide by that monomial. And I would write it out like this. So you're going to have 5a squared b divided by 5ab minus 15ab cubed divided by 5ab plus 10a cubed b to the fourth divided by 5ab. Okay, and now you simplify each term. So we're going to simplify each term. So if I look here, my 5's cancel. This a on the bottom cancels with one of these and leaves me with a to the first. And this b cancels. So I am left with just a for that first term. Here, 5 goes into 5 once and into 15 3 times. The a's cancel. They're both to the first power. This b on the bottom cancels with one of these and leaves me with b squared. So my next term will be minus 3b squared. And then on the third term here, 5 goes into 5 once and into 10 twice. The a cancels with one of these and leaves me with a squared. This b cancels with one of those and leaves me with b to the third. So if you notice for the last term, I have 2a squared b cubed. So you end up with this answer for that problem. Okay. Now we're going to look at dividing by not a monomial, but by a binomial, a two-term polynomial. Okay. And we've listed some steps right here that you need to follow, and this is for what we call polynomial long division. Okay. So if you think back to what you did with long division of numbers back in elementary school, when you first started looking at that, it's very, very similar. Okay, so, but it's just dealing algebraically with it. So this is what's going to go underneath, okay, the division symbol. Okay, so, and then this is what we're dividing by. So I'm going to have x minus 5, and then that's going into x squared minus 2x minus 15. Okay, let's do a problem over here back the old way. Let's say this. Let's say I had 19, because I want to relate it to long division. Let's say I had 19 into 508. Okay, so you ask yourselves, how many times does 19 go into 50? Okay, and you say twice. Okay, so what we're going to do up here is we're going to ask ourselves, take the first term of the binomial, so that's the x. How many times does x, this x right here, go into x squared? In other words, we're doing step number 1 here, over here on the right. X times what? So step number 1 right here. X times what gives you the first term? So x times what will give me x squared? Okay, and that is x. So I write that right up there. Okay, now if you think back over to this, what did you do with the 2 once you wrote it up here? You took 2 and you multiplied it by 19, which gave me 38. Okay, so I took this and I multiplied by this. Well, that's what we're going to do right here, except for it's algebraic multiplication. We are going to take x that we just wrote up above there, and we are going to multiply it by the divisor, which is x minus 5. Okay? So I'm going to take x times x minus 5. When I do that, we're going to distribute. So I get x squared minus 5x. I'm just distributing my x. Okay, so that's what we did, is we multiplied. All right? Then if you think back over to the numeric long division, what you did next is you actually subtracted. You took 50 minus 38, and I got 12. Okay? Well, what we're going to do and how you treat it algebraically is, okay, so we did the distributive property right here. Now we're going to change signs. Okay, we're going to change signs because that's how you deal with subtraction. These two steps is how you subtract algebraically. Okay, change the signs and add vertically. So this was a positive x squared. We are going to make it a negative x squared right here. Okay, this was a minus 5x, and we are going to make it a plus. Now what I do is I keep my original sign there and I put the new sign above it. Okay, because now when I add, I have x squared minus x squared, which drops out. And that will always happen with your first terms in the column. It's 0x squared. And that's we chose that because x times x gave us x squared. Now I combine negative 2x. Now it's plus 5x, which gives me positive 3x. Okay, so I basically have done what I did up to this step over here numerically. So now what you did over here is you carried down the next digit, which is 8. Okay, and then you ask yourselves, how many times does 19 go into 128? Okay, which I think is 6. Okay, all right, so now we're going to we're going to do the same thing over here. We are going to carry down our next term, and we're going to carry down the minus 15, keep the sign that's on it, and now we're going to kind of repeat the process. So we drop the next term right here, and then you start over, asking yourselves, how many times does x, or how many times does this x go into this? Or x times what is 3x? Well, that's positive 3, so I write it up there. Okay, now if you think back over here, then you took the 6 and you multiplied it by the 19. Okay? Which ends up being whatever, and then you're going to subtract again. You kind of repeat that process. Okay, well that's what we're going to do right here. Now we just wrote positive 3, and we're going to multiply that times my divisor of x minus 5. So I distribute, and I get 3x minus 15. Change the sign, change the sign. These drop out. And actually, on this one, we get a remainder of 0. Now, many problems, the remainder will not be 0. In this case, it is. Okay, we'll talk about dealing with the remainder a little bit later here. Okay, so if the remainder is 0, your answer to the problem is what you have up here. So really what you're saying is, if I had x plus 3, and I multiplied it times x minus 5, you'd FOIL that. If you FOILed it, and you could check this if you wanted to, I'm not going to go through that whole process. If I actually multiplied that, I would get x squared minus 2x minus 15, which is what we had right here. Okay, so it's very similar to numeric long division. Okay, let's do another one. So here's my divisor. I'm going to start with x minus 4. And I'm dividing that into x squared plus 2x minus 24. Okay, so I ask myself, how many times does x go into x squared? Or x times what gives me x squared? First term here, how many times does it go into that? And that is x. Take what I just wrote up there, which is x, and I'm going to multiply it times my divisor here of x minus 4, or I distribute it. And I'm going to put that result right here. I get x squared minus 4x. Okay, now I draw my line. I'm going to subtract. How you deal with it algebraically, you change your signs. So that becomes a plus right there. These drop out, x squared minus x squared, which always happens. First ones will always drop out. I have 2x plus 4x now, which is 6x. Remember, you changed the sign there. Okay, now you drop down your next term, which is minus 24. Okay, repeat the process. How many times does x go into 6x? Or x times what is 6x? So if you think about it, x times what is 6x? Well, that would be times 6. Positive 6, so I'm going to write plus 6 there. Take what you just wrote, which is your positive 6, and I'm going to distribute that to my x minus 4. And I get 6x minus 24. Okay, now you're going to subtract, or algebraically change the signs and combine like terms. These drop out, and notice you do get 0 when you take negative 24 plus 24. So this one, again, the remainder is 0, similar to the last problem that we did. So your answer would be x plus 6. Okay, now we're going to look at one with a remainder. Okay, so if we look here, first of all, what I want you to notice is we're taking a squared minus 5a plus 3, and it shows multiplication. It doesn't start out as division, but notice you have an exponent right here on this binomial of negative 1. We are going to rewrite this as a squared minus 5a plus 3, okay? That's on top. Remember, with a negative exponent, you move it down to the bottom part of the fraction. So we're dividing by 2 minus a, and that's going to be to the first power. Okay? And I am going to actually rewrite this. So we really have a squared minus 5a plus 3. If it's to the first power, we can really just drop off the parentheses. So I'm dividing by 2 minus a, except for we want our variable term to be first. Now notice the a is negative, so we're going to divide by negative a plus 2. Okay? Negative a plus 2. So let's set up our long division. So we're going to do negative a plus 2. That's what we're dividing by. And into long division, a squared minus 5a plus 3. Okay, so I say, how many times does negative a, my first term here in the binomial, go into a squared? Or, think of it this way, negative a times what is positive a squared? Well, it's got to be times a negative, and it's actually times negative a. So I take negative a and distribute that to negative a plus 2. I get a squared minus 2a. Well, now I'm going to subtract. So I change to the opposite, change to the opposite. A squared minus a squared drops out. Negative 5a plus 2a is negative 3a. Okay, now I'm going to carry down my positive 3. So now I say, how many times does negative a go into negative 3a? Or negative a times what is negative 3a? And that is positive 3. So I take positive 3 times negative a plus 2. Distribute. It's negative 3a plus 6. Don't forget to change your signs here. So this becomes plus. This becomes minus. This drops out, negative 3a plus 3a. Now notice we don't get 0 here. Positive 3 minus 6 now is negative 3. This is called our remainder. So what you do is you take and you put that remainder of negative 3 over the divisor, negative a plus 2. Okay, so if you go back up to the choices, you can figure out which choice it was. It's negative a plus 3, and then negative 3 over a plus 2.